Hi guys, Mr. Bennett here. Today we're going to look at an example where we're going from a ground to above ground, and the initial conditions are launch. We're launching a ball 20 metres per second at 30 degrees to a hoop that is 2.5 metres high and 30 metres away. The question is, does it go in the hoop? Right, so if we're looking at that scenario, what we would need to do in order to have our information in there. Alright, so obviously the ball's been launched there, probably going to go above the hoop, and then it's going to go there. So we know this distance here is 30 metres, we're hoping, and then we're hoping that the launch angle is, in fact 30 degrees. Alright, so anyway, we're going to go through this problem as you would need to, each step. So the first thing that we have to do is work out the horizontal and vertical components. So we know that there is 30 degrees, we know this is here over here is 20 meters per second. So we could say the vertical component is equal to 20 sine 30 degrees, and we know that the horizontal component of that is going to be 20 cosine of 30 degrees. Remembering this is sort of pretty easy. So go to your calculator and you go 20 sine 30, enter, that's 10. We do 20 cosine 30, and that's 17.3. So if we go back to our thing, we know that's 10 meters per second. We know that's 17.32 meters per second. Alright, so that's really crucial that you can do that. Alright, the next thing that we do in our step is to work out the time it takes to hit the ground. Alright, so we know we're going to a height of 2.4 meters, so our SV is going to be 2.4. We know initial vertical velocity is 10, we don't know t, minus 4.9 t squared. Okay, so therefore we need to rearrange that. Alright, so we have minus 4.9 t squared plus 10t. Now because that comes over the other side, it's going to become minus 2.4, and that's now equal to 0. Now you could graph this on your graphics calculator, and that's certainly one way of doing it, but the easiest way to do this is to go to your apps button, if I can get mine working. See if I can get that working. Go to my apps button, doesn't seem to be working. What we'll do is we'll graph it. Just close that. For some reason that's actually not working. Open that up again. So it's really about just going to your graphics calculator and finding the answer there. But I do want to show you how to do that. So it's important. So if you go to your apps button, if you go to alpha P, you should have this particular program on your calculator called PolySimp 2. So you go into there, and the thing that we want to use is the root finder. Alright, so we're going to do number 1, and so we're going to do a quadratic, and so we're going to go next. So the value for A2 is always going to be negative 4.9. Our A value is going to be our initial velocity, which was 10, and then A0 is going to be our height. In this particular case it's minus 2.4. Remember when we had to actually bring it across, and then all I have to do is press solve. Now you're going to get two values here. The value that we're looking at there is 1.76. Okay, so that's the value that we're actually looking at, is where it's going to be near the hoop. Alright, so if we write that down, right, so therefore t is equal to 1.76 seconds. So that's all I really want to get. I mean, you don't have to do any more than maybe solve on graphics calculator. Alright, so but it's not a maths question, so it's a physics question. Now, to work out our range, SH is equal to simply our VHT, so that's going to be 17.32 times by our time of flight, which is equal to 1.76. Okay, that's going to give me an idea if it's going to be around the right distance. Now, from here, you're going to have to go back and get out of that program. And 6 will get me out of there. So if we've got 17.23 times by 1.76, that's going to give me an answer about 30.48. Okay, so 30.48 is going to be the range to that particular height. So that's going to mean it's got a chance, doesn't it? Alright. The next thing we want to do is we want to calculate the vertical velocity. Okay, the vertical velocity, keeping in mind the horizontal velocity doesn't change. Right, so we might want to actually find its vertical velocity at 1.76. Okay, so the first thing that we have to do is go, our velocity is equal to our initial vertical velocity plus AV times by T. Right, we know our initial vertical velocity is 10. That's going to be minus 9.8 times by a time which is 1.76. So go to your calculator to do that. So 10, take 9.8 times by 1.76, and that's going to give me minus 7.25. That would be close enough. That's equal to minus 7.25 meters per second. Remembering that means it's just moving downwards. And then to work out our velocity is going to be equal to square root of the horizontal velocity, which is going to be 17.32. Remember, that's not changing. And then it's going to be plus 7.25 squared, and that will give us our velocity at that particular point. So again, we've got to go to our calculator, so might as well do that one step. So square root of 7.25 squared plus 17.32 squared. Now we know with our answer, obviously it's going to be bigger than both those values. So that's going to be 18.77. 18.77. Okay, at that particular time. Now remembering, it's at this particular stage, what did we launch it at with 20? Right, so we're talking about when it's actually at a height of 2.4 meters, so you wouldn't expect it to be going as fast as what it was launched. Alright, and then we might want to find the maximum height. Okay, so the maximum height is the thing. Now remembering, at the top of the launch here, as it goes through there, that has a vertical velocity of 0, alright, at that particular time. So we use the same formula. V is equal to V0 plus AVT. Now we know that's equal to 0. We know that's 10 minus 9.8 T. So therefore bring that across, minus 10 minus 9.8 T. So therefore, now the negatives will cancel out. So T is equal to 10 divided by 9.8, which will roughly give you something about 1 point something. So let's do it. 10 divided by 9.8 equals 1.02. No, you might as well just say it's 1 second. But we'll do 1.02 seconds. Now that tells me my particular thing here. The next thing I need to do to work out the height of it at that particular point is to put it back into the SV formula. SV is equal to VV0, that's 10 times by 1.02, take 4.9 times by 1.02 squared. Remember, that's half of gravity. So do it on our calculator. 10 times 1.02, take 4.9 times 1.02 squared. Now a lot of people forget the square bit there, so don't do that. That's 5.1 metres. That's equal to 5.1 metres, and so we've actually found that height. Now remembering the hoops at a height of 2.4 metres. Now, in order to work out if it's actually going to go in the hoop, now we know with this question, because we haven't really answered the question, will it go in the hoop? Right, it does travel a distance of that, so it's at that distance at 1.76 metres, isn't it? Alright, if we know the time, we could actually work out the vertical height there too, couldn't we? We could say here SV is equal to, now initial vertical thing is going to be 10 times by 1.76, take 4.9 times by 1.76 squared. So we did that calculation. So 10 times 1.76, take 4.9 times 1.76 squared, enter, we get a height of 2.4 metres, right, 2.42 metres. So that means that the basketball or the ball, soccer ball, whatever you're kicking at the target, we actually would have a chance of possibly hitting the ball at that particular stage, because the horizontal distance about right, the vertical height's about right, so therefore we'll get a chance for that. Anyway, the idea of this is to go through and show you how to do a question. The only real difference between this one and the previous question is our initial height. Okay, we need to account for that, and then the way that we actually work out the time of flight using our graphics calculator. Right, remembering we're doing a quadratic there, and I know you've done that in maths, so that's really the only difference. Again, we just use our calculator to solve that. So, anyway, good luck with those questions out of the textbook. Now you need to identify that type of question and then just go through those steps.